Hi, everyone, and thanks for joining today's webinar. My name is Ben Sawyer, and I'm the webinar host here at Hazelcast. In today's webinar, we'll be joining Hazelcast Senior Solutions Architect Chris Engelbert as he walks us through the 10-step guide for taking Hazelcast IMDG into production. We'll be looking at the most common pitfalls for handover between developers and operations, as well as how to solve these issues firsthand. And without further ado, I'm going to turn the webinar over to Chris.
Okay, thanks, Ben. Hello, everyone. As Ben already said, I'm Chris. I have a slide about me in just a couple of minutes. But first, I want to cover one specific thing because there is so much stuff. So while I was preparing this presentation, there is so much stuff I want to talk about. Unfortunately, I can't fit it all into the 1 hour session, so I think we could make it like 4 hour workshop, whatever. There is a full IMDG, Hazelcast IMDG deployment operations guide. For your convenience, I made it like a short link on Bitly. So I really recommend downloading that and reading it. It talks about a lot more things and in a lot more detail. But the idea of the session is to give you a nice idea or a quick insight of what you actually want to look out for when you deploy Hazelcast into production. Okay, with that, as I said, I'm Chris. I'm Senior Solution Architect at Hazelcast for the DACH region, so for Germany, the German-speaking areas, like Netherlands and stuff. But I'm also Manager of Developer Relations, so I'm talking with the open source community, speaking at conferences, those kinds of things. You can find me on Twitter. You see the username there, so I don't want to mention it. I'm doing Java for a long time. I actually stopped counting after 10 years, so I'm probably much older than you expect. I'm not sure if that is a good or a bad thing. And most of the time, I'm doing stuff related to performance garbage collection. So the general things that people in the Java world don't really like. So that's what I do for my fun. Because this is more like a DevOps kind of session, I wanted to give a short introduction in what Hazelcast is. I'm not sure if everyone is 100% familiar. I mean, some of the operations teams just get Hazelcast from developers. They normally don't have like a real insight. So I try to give like a really fast and simple overview, a high-level overview of Hazelcast. So what we are an in-memory data grid, which means we store information in memory. We can run calculations on top of that. We can run computation on top of that. But we can also make it just available for fast access. That said, Hazelcast is normally used whenever you need extremely fast access to the data. Obviously, you can't really get faster than RAM. Disk, SSDs, everything's slower. The only thing faster is L2 cache, but we're never gonna fit our data into that. So Hazelcast gives you this near real-time, soft real-time insight into all your data and this amazingly fast access. Common use cases for Hazelcast, as I already said, caching, the whole data grid, which is the computation, the distribution of processing, the distribution of calculations and operations, but also for microservice infrastructures, so caching between different microservices, a caching layer on top of a database, but also things like simple state sharing. We're going to see that later in the presentation. The biggest, or the last big part for Hazelcast is web session clustering. For people that have Tomcat, Jetty, or Surflet containers into production, you can actually use Hazelcast as the middle tier for multiple of those instances to share the same session store and to make it available for fast failover. So just put a load balancer in front of it and you're good to go. Coming from the ecosystem, Hazelcast is way bigger. So it doesn't always mean you have to deploy Hazelcast in itself into production. You see there's a lot of open source and sometimes closed source applications or systems that also use Hazelcast underneath and deploy it together when you deploy. For example, things like Payara or WSO2, they use Hazelcast internally. So you might have had Hazelcast into production already without even knowing it. From the feature side, Hazelcast is pretty versatile. We have a lot of different things. I'm not going into detail because that would be more like the developer side of things. We're having a lot of webinars for developers. We actually have any kind of, or almost any kind of data structure that developers need, like lists, simple lists, key value stores, those kinds of things. But we also have the computation layer, so you can put computation into the cluster, moving the computation to the cluster. So you have a compute grid, or you just want to run simple aggregations, computations on top of the data that is already stored. We provide plenty of different language clients. On top, you see Java, C++, .NET, Python, Node.js, Scala, Go is in the process. So with the same Hazelcast cluster, you can leverage a lot of different, or you can utilize a lot of different language clients. And the rest is pretty much very in-depth. On the right side, though, you see the blue layer, which is security management center, so monitoring, data center replication, rolling upgrades. We're going to see a couple of those things later in the slides. So it's just like you know about those kinds of things. Okay, and I think that must be enough as a high-level overview. So it's, as I said, it's just so you have some idea of what we're actually going to talk about. So the first thing when you go into production that you have to think about is the Hazelcast cluster topology. Hazelcast by default, or Hazelcast offers two kinds of deployment strategies. The first one is the embedded mode. That means the developer is putting Hazelcast into its own application, and when you deploy the application, which is probably developed in-house or you bought it, then the application itself will create a Hazelcast node and will cluster itself. That has a couple of use cases. For example, for development, it's for rapid prototyping, but it is also a very common thing you see these days for microservice style deployments, where the microservices share their own state or information between the different instances. And those kinds of state could be simple stuff like rate limiting, those kinds of information. The other part of Hazelcast, or the second deployment strategy, is the so-called client-server mode. You can expect that as some kind of a database-styled deployment. So you have one Hazelcast cluster. From your application point of view, it looks like a single point of entry or a single point of failure. However, Hazelcast really does make sure that every client is connected to every node. So even though one node fails, there is no such point as a single point of failure. So that is the commonly recommended setup for production. That is what we recommend when you really store data in Hazelcast, or if you put computation into Hazelcast. So as I said, the embedded mode is more for microservices, for OEM. So OEM partners can integrate it into their software, pretty common thing as well, or rapid prototyping. But whenever you have to scale to a later point or scale out, we normally recommend the client-server mode. For microservices, though, so there's two different styles of how microservices are normally using Hazelcast. One is, and you have to imagine on top of the Hazelcast IMDG layer, there would be like a database, an Oracle, an IBM, SAP, whatever you have in-house. And you have a big Hazelcast cluster in front of all the different microservices. You see there's microservice type 1, type 2, type 3, type 4. You have either multiple or one instance of the microservices, and they're all sharing the same database cache, the same way they would share the same database. However, a lot of people say, well, that is not the way microservices are supposed to be, right? Normally, microservices have to be isolated. So the second way is going for maximum isolation. And in this case, you often have Hazelcast built, or the Hazelcast embedded mode built into the microservice. In this case, you often don't store that much amount of data. And for that reason, it is pretty good. It is okay to go that way, but this is development. So developers decide to put Hazelcast into it, except they give the operations team the option, because from development side, it doesn't really make a difference to us. So if you have the feeling, or if you have an application, you have the feeling you want to deploy it as client-server architecture, feel free to ask to your developers. It's fairly easy for them to switch over the different modes. If you have a microservice architecture and you have a Hazelcast embedded, but you still want to store plenty of data, you often go with the combined approach. So I put the two pictures together. So your microservice type 1 on the bottom, for example, would have a Hazelcast embedded cluster for just sharing those state data. As I said, information like rate limits, how much requests this account already used of its quota, those kinds of things. But in front of the database, you might still want to have a full-blown Hazelcast cluster for storing the information coming from the database. So you can perfectly fine also combine those two approaches into a single thing. That is pretty much the way we go here. I'm not sure if you actually can see there are two different cities in this slide deck. So there is one more thing I really want to cover, or I quickly want to cover. That is data center replication. So you might have to have multiple data centers. And Hazelcast gives you the option to have two different Hazelcast clusters. And those clusters can work in different ways. So you can interconnect those two clusters, and they can either use the one-way replication. That is pretty much you would have a live data center, for example, in London, and you have a one-way replication to the data center in Paris. And when you figure out that something is wrong in the London data center, you switch over, you fail over to Paris. So that is the first thing. The second thing is that you can actually have a two-way synchronization. And two-way in this case means you have two live clusters, and you can change information on both sides of the cluster. That could be, for example, a geographical kind of clustering technology, right? So you have one in Europe and one in the US and one in Asia, for example, and customers always get to their closest data center. But in this case, obviously, you might change the same data on both levels or on both sides, so you might have to do some conflict resolving. In this case, you definitely need help from engineering again. But the interesting thing is that you can really do those kinds of, as here, London and Sydney, so you can have a geographical close-by cluster technology to your customers for fastest access. And as I said, we unfortunately have to go pretty quick. So if you have any question, feel free to put it into the Q&A section before we go on. I'm just going to mention it again. I hope we have some minutes afterwards. If not, I do my best to collect all the questions and answer them via email, and we're going to send them around afterwards. So the second thing you really have to think about is the runtime environment. And I think that is more like a very, very important thing, because so from the easy part is we support Java 6, 7, 8, and we're going to support Java 9 when it comes out. We support OpenJDK, Oracle JDK, IBM J9, Azul Zing, Azul Zulu. So pretty much every of the bigger Java environments is completely supported, and you don't have to think about anything like that. So that's the easy part. The harder part actually is Hazelcast always recommends dedicated hardware. I know this is against today's trends, but the reason is simple. When you have a cluster with high load, high read rate, you really don't want to have the hardware or the resources being shared. So Hazelcast itself always recommends dedicated hardware. However, we understand that is normally not going to happen. at least not today. So from an operating side point of view, we always recommend Linux, and we recommend either CentOS, Red Hat, or Ubuntu. We are certified for IBM iX for the banking customers that still use it. We definitely have some. We support Windows, and we support Oracle Solaris on Spark platform. I'm not sure if we have Solaris and anything else, but normally you find it on those bigger Spark systems. So as I said, that is for dedicated hardware and obviously for the cloud as well. So the other thing we support is the private cloud. So everything you build in-house, build in your own data centers, but obviously also like public clouds. The important thing whenever you go into the cloud, and I unfortunately can't stress this enough since we have a lot of bad experience with that. If you use Hazelcast on any kind of cloud platform, no matter if it's public or private, please do not overcommit hardware resources. Hazelcast expects the allocated resources to be available, and we're going to use them. That means if you overcommit, for example, RAM and Hazelcast, you have 5 or 6 Hazelcast nodes on this physical machine, and all the Hazelcast nodes are about to require or allocate the expected memory, you probably run into issues. So overcommitment of hardware is like the biggest issue we have with any kind of cloud environment. So please stay away from that. Coming to the infrastructure side of your cloud, it is pretty easy again. We support Pivotal Cloud Foundry, OpenShift or Red Hat OpenShift, and Amazon AWS out of the box. We support Heroku, Azure. We support pretty much any kind of available service discovery like Zookeeper, etcd, Kubernetes, whatever. And Hazelcast also provides Docker images, and you can deploy it right away into the common systems. But we also are certified VMware partners, so we have a lot of customers and users running on VMware. For VMware, there's only one special thing: please don't use vMotion. It will definitely hurt your cluster. So stay away from vMotion. Otherwise, you're perfectly fine to run with VMware as well. From my experience, still one of the most common runtime environments in terms of virtualization we see. Cluster sizing, and that is also something which is really, really hard sometimes and really important. So there are a couple of different ways how you can actually size your runtime or size your Hazelcast cluster. Let's start from the right way. So with Hazelcast or with Java in general, you always have this problem that you have the GC heap area. That means that if your heap is too big, you will have or you will end up with big GC pauses. And GC pauses are not a good thing for latency. They're very unpredictable. So what a lot of people do is they start a lot of small JVMs, very small heap, but this becomes obviously very complex to manage and to organize. And as I said earlier, every Hazelcast client will connect to every Hazelcast node. So in the end, you have a lot of TCP connections. The other option, or that is the middle. You make a bigger heap and you start to put a lot of effort into GC tuning. This also goes hand in hand with engineering, putting some changes into their code to create less garbage for your garbage collector to collect. That is very time consuming, but it works as well. It works well as too. So that is the way to go. But as it says, it's a pretty much constant battle because for every single update, you're gonna do it again. And the third way is you suffer from those GC pauses in general. So in this example, we have 64 gigabytes heap. And the second the garbage collector kicks in the worst case, you have like a major GC pause time, and a Hazelcast cluster kicks out members when it expects those members are not reachable anymore, they're dead or whatever. And that could mean They're just in a GC pause, but because they're not reacting to a heartbeat, we throw them out of the cluster. So that is definitely a problem. One way to solve this issue, and I'm mentioning the enterprise features just very briefly, is HDMS. That is a technology developed by Hazelcast that makes it possible to store data outside of the garbage collected heap area, which means the garbage collector doesn't have to work with that. It goes back a little bit into these times of the older C++ application, so we're managing this memory area ourselves, but it gives you two very interesting features. The first thing, and that is what the picture shows, is you have the option to allocate a lot of memory because you're not suffering from GC anymore. So you can store way more data inside of a single machine. The second way, or the second feature is, even though you have way less data, maybe just 4 or 5 gigabytes of data, because the garbage collector doesn't really have to do anything, you get an extremely predictable runtime behavior, extremely predictable latency. So that is mainly coming from use cases where predictable behavior or predictable latency is very important. I wouldn't say lowest possible latency, I would say predictable or latency sensitive. That's the term that I normally use for that. The way Hazelcast stores data internally, so we talked about the GC, and as I said, you can have very, very much or a lot of very small JVMs. So the way Hazelcast actually stores the data is in a so-called partitioned way. For people that are more familiar with the relational database terms, they normally call it sharding. So you have a subset of the overall data set on all the different machines. And that way, if you add more machines to the cluster, you get a better spread of the data, and you also get less data into a single machine, obviously. So that is a way to attack the GC problem. Most of the time, it's easier to go with HDMS or anything like that. So the cluster is built of multiple members. The actual data partitions, you can imagine that kind of like in a hard disk. You have some kind of partition table which assigns partitions to the different members, and the data actually resides inside of a single partition. And whenever you put or get something, we calculate the partition this element belongs to or this key belongs to, and we access the right partition on the spot. By default, we have 271 partitions, and that is okay for about clusters up to a size of 50 nodes. When you go further, you should definitely increase this number, about that later, and up to about 30 gigabytes of data. Not 30 gigabytes heap, but 30 gigabytes data. In general, a partition size shouldn't be bigger than 50 to 100 megs, because when we have to move the information or the partition to a different node, because you add a node or you lost one, you want this partition to move fast. One more thing that is very important. By default, we keep one backup. And you see there's a lot of information here. We keep one backup. You can increase the number of backups. You can completely shut it off. That should also be a consideration for your specific use case. And we recommend to never go over 75% of heap usage if you're on heap. So if you're not using HDMS, better, depending on the GC configuration, not go over 60%. And you should always remember that if one node fails, obviously the other nodes have to take over the additional information or the additional data, which means they have an increased heap size at that point. So that should all be put into consideration for the size itself. As I said earlier, Hazelcast recommends dedicated hardware. But if you can't have dedicated hardware, you should have at least something which is kind of similar to a minimum of 8 cores. So we're using a lot of threading internally, and about 8 gigabytes of RAM minimum if you run on heap, and if you want to store data on heap, or 2 to 4 gigabytes for HDMS depending on how much data is actually stored. One more thing we actually recommend, and this is at least for private clouds possible. I think Amazon also has this option for their public cloud infrastructure. Use a dedicated NIC. Hazelcast has a lot of internal traffic, and we expect traffic to be extremely fast. So everything that blocks or that delays the traffic on a NIC or on the network will actually increase your latency and will give a poorer feeling about the speed of Hazelcast. So a dedicated NIC and maybe a dedicated network is amazing. If you can't do that, well, I mean, 10 gig is still amazingly fast. Just one short slide so you see the difference between on-heap and off-heap storage, or on-heap and HDMS. In this case, we store about 4 gigabytes of data, and we see for on-heap we have 9 major and 31 minor GCs. For the HDMS, we see we have no major GCs, so no stop-the-world pauses, but a lot of minor GCs, but they're way faster in general. So we have 4.2 seconds to less than 0.4 seconds. So that's the main idea, just so you know. Okay, data migration and updates. And here it becomes a little bit more complicated. So Hazelcast clients in general have the option to talk to different cluster versions or cluster member versions. So that said, as you see on the picture, you might have a 3.6 client, 3.7 client, and a 3.8 client, and they all accessing the same data, which is running Hazelcast version 3.8. So that works perfectly fine because there's a version-independent cluster protocol between members and clients. And that makes it easy to upgrade the clients independently. That was the important thing. However, we always recommend, if you go into an upgrade cycle, and we definitely recommend to upgrade Hazelcast to newer version, please update the cluster first. So on the top, we see this big 3.8. That is the Hazelcast cluster, and we always recommend to update this one first to prevent that clients might have some functionality or some features that are not yet available by the cluster, and you get some exception which is not expected because normally this functionality should be available. So the way, if you update the cluster first and then you update the clients, that means this problem goes away. So that means after we updated the cluster, we're gonna go around and update one client or one client application after another. This also gives you the freedom of deploying independent microservice, independent applications that access the same clusters or the same cluster independently. So you don't need a full release train where everyone has to be at the same version all the time. And eventually everything is on 3.9. So that is the main goal. So that is how you update the client or the clients. The other problem is how you actually update the cluster itself. And therefore, we have two different options. The first one needs a maintenance window, and I guess it's kind of self-describing, right? You're actually going to have a downtime of the cluster. That means you have a running cluster, and we don't have started the upgrade yet. Everything is, for example, on version N. And we shut down the whole cluster. All information is lost, or all information is stored somewhere. We update all the Hazelcast versions of the different cluster members to version n.1 or n+1, and we start it up again and reload the information. I think that is the obvious kind of possibility, but obviously nobody today wants to have downtime, and maintenance windows become more and more uncommon. So the other option is to do the cluster upgrade in a rolling upgrade fashion. Again, we have a cluster and there's no update running. Everyone is on version N. And now what happens is you update one node after another. The important bit here is make sure, so Hazelcast has some health checking, and we're coming to that a little bit later. Make sure that the cluster status or the cluster health is always healthy or full. I'm not sure. I think it's healthy, because otherwise you definitely will lose information. So shut down one node, update this one node, start it up again. Wait until the cluster is healthy. Go on with the same procedure for the next node. You shut it down, you upgrade the version, or you redeploy, and you start it up again. You wait until the cluster is healthy, and you do the same thing. And in the end, after everyone is on the new version of the software, you actually have to commit this operation, which means you can either configure it to be automatic the second all nodes are upgraded. Please switch to the new cluster protocol, which for example, could be 3.9 right now, or you have configured it to be manually. That means you have to go to the management center or to the REST API and say, okay, I updated all the nodes. Please commit this upgrade operation. We're finished. We want to have all the data on the same or on the new cluster protocol level now. One other enterprise feature which is coming along with HDMS is hot restart. That is also a very specific use case, especially if you're running on dedicated hardware. As I said, you see, we're always coming back to the dedicated hardware. This gives you the option that Hazelcast snapshots the current content in memory onto hard disk. We recommend SSDs for the obvious benefits of write and read speed. The way it works is, as I said, you have snapshots on an SSD, and when you actually restart the cluster will reload this information from disk instead of going down to, for example, a relational database or some other thing. That means we can reload information extremely fast. In this example, it is 100 gigabytes per node on a 10-node cluster, so 1 terabyte of data, and you can reload this in under 100 in under 100 seconds. That means if you really have to shut down the cluster at some point, that makes it extremely fast to minimize, or extremely easy to minimize, the maintenance window time. Security, and we're about half in the time, so it seems like I'm good in time. Security, very important thing, right? You actually have different options to encrypt traffic in Hazelcast. First of all, you can have symmetric encryption, which is AS, Blowfish, DS, the common patterns. And the second thing this diagram shows, you can actually encrypt the traffic between cluster members. Obviously, you can also have TLS encryption, so certificate-based encryption, or better said, private key-based encryption. But this also shows you also can encrypt the traffic between the cluster and the clients. Obviously, it doesn't make sense to only have one. So we have synchronous, we have asynchronous encryption, and you remember the WAN replication or data center replication. You can obviously encrypt the traffic between the different data centers as well. However, for that use case, I would always recommend to have a hardware VPN doing all this encryption in hardware. With the new Hazelcast version, I think it's 3.9 upcoming right now. So the version is 3.9, but I think the feature is coming in 3.9. We actually integrated the OpenSSL stack into Hazelcast, and by that we doubled the throughput for encrypted traffic to be almost the same as unencrypted. So if you're currently using Hazelcast with encryption on a lower version, you definitely figured out there's some decrease when you enable, or a decrease in traffic when you enable encryption. That is going to go away in the new versions. So encryption should be a must-have these days, and therefore it needs to be fast. So encryption is on one hand, or is one side of the security chain, but obviously there's more stuff to go. When you have encryption, you might also want to have authentication and authorization. So maybe not every client is allowed to connect to every cluster if you have multiple clusters, or if you have a big shared cluster, not every client is allowed to access all different data structures. So those kinds of things are easy and possible. Hazelcast actually supports the JAS mechanism. JAS stands for Java Authorization and Authentication Services, or the other way around. I would always mix it up. And that said, you can integrate things like Kerberos, certificate-based authentication, LDAP, Active Directory, all the good bits that are normally already available in the common infrastructures in bigger companies. And as I said, they can either go down and say, okay, either this client can't connect at all, or based on roles, you might have specific access points. The way it works is you can actually configure any kind of operation in Hazelcast for every specific user. So you can say client 1 can connect to map A, client B can, and read-write, client B can connect to map B, but can't see A, and those kinds of things. So you can go pretty deep and pretty detailed about security. The other thing is we actually have interceptor levels, and this interceptor is even before authentication. So you could, for example, put in an interceptor and say only nodes from 10.00x or 10.00 asterisk can connect to the cluster. And when somebody coming from another 10.01 network, this interceptor will automatically block it off. So you don't even go to the authentication. So if you have like really bad people, and I don't expect this to happen in companies, you can't even go into a denial of service based on the authentication. The other thing is the interceptor, and that is what I was talking about. The second interceptor is the permission-based interceptor or operation-based interceptor. So you can see that you actually have an interceptor that qualifies put and get requests, and that way you can go extremely deep. There is a full permission system built in, so you don't have to use the API, but if you have specific use cases or specific requirements, you can actually go pretty deep. Health check and monitoring. And that is what I mentioned earlier. So there are different ways of monitoring Hazelcast. For the people that seen it or that have seen it so far, Hazelcast has a management center, which has a UI, but also some other features. And whenever I talk to customers, there are two different deployment strategies. I'm normally going for the second one as a recommendation, and you might see why. So, as I said, there's two different ways of using Management Center. The first one is more for smaller companies that don't have a full-blown monitoring infrastructure yet, or obviously for development, because during development you might want to see things are going smooth, and the cluster is actually what you expect, or does what you expect it to do. So you have your cluster. You deploy Hazelcast Management Center as a standalone thing. So you can either start it standalone. It is a full-blown Java program, embedding its own web server, or you can deploy to any kind of servlet architecture, servlet container, like Jetty, Tomcat, WebSphere, whatever, those kinds of things. And the way it works is the cluster will be configured to actually push the information to Management Center. That for the reason, if the cluster is under high load, and you would pull information, you would just increase the load on the cluster. So we want the Hazelcast cluster to do what it is designed for: offer the access to the data, offer the access to the operations, and the actual push mechanism is a low priority thread. So under a very high load situation, you might get an update slower than in normal condition. Maybe not every 5 seconds, but every like 6. But the cluster tries to do what it is meant to be, and that is offering access to the data. That's the reason why we prefer push over pull. And then you have your operator, and the operator actually uses the Hazelcast UI. So it will access the UI, and that is how you actually make a happy operator from any kind of operator, right? So the Hazelcast UI has a couple of different features. So you see the common statistics you would expect. That is the different heap sizes, the different heap load, or the usage of the different heap sizes, how the stored data is actually spread around the cluster, what are your average min-max latencies, get access, put access, those kinds of things. So you see quite a lot of information. I think there is one more. So in this case, we have how many entries are in each of the members, how much memory those entries use, how much memory is actually stored for, or how much memory is used for backups, how many backup entries are around, all those information you normally want to see from any kind of monitoring solution. As I said, it's meant for a little bit of for more of the smaller companies. So alerting functionality is pretty limited. You can add an alert for pretty much everything in the system. However, alerting can only be sent out using email. So that is definitely a limitation, especially for bigger companies, as I said, when you have like a full-blown monitoring infrastructure. So the second way to go is you still have your cluster and you have management center. And the cluster still pushes the information to management center, but this time we're using management center just as a proxy to access the information. Proxy in this case means it is still deployed somewhere, but you leave the API being an API, the UI being an UI, and you're not using it. But Hazelcast also, or the Hazelcast Management Center also offers the information as REST and JMX. So you get all the good data right from Management Center, and you can retrieve it and put it into Zabbix, any kind of APM like Dynatrace or whatever. There is actually a third way. I'm just going to mention it. We have JMX on the nodes itself, but please don't do that. So you can access JMX on the nodes, but JMX is a very GC unfriendly protocol, and you've seen we're already fighting the GC, so please don't activate JMX on the nodes itself. Always use Management Center in the middle as a JMX proxy. Because in that case, it doesn't matter if the GC on the Management Center is like 5 or 6 or 7 seconds. Okay, now we have the data inside of our monitoring solution, and obviously we have the operator accessing it and making it a happy operator again. Coming from my own experience, and I did a fair share of DevOps as well, I would always go for the second setup, but I always worked in bigger companies. So I understand that for smaller companies, the Hazelcast Management Center UI is amazing and it's perfectly fine. Here is just, as I said, we have all the information in JMX. This time it is viewed by, I think it's JConsole, just the mbeans. So there is all the information you expect, but you get all the information using REST as well. And there are some APM systems that have a direct integration into Hazelcast or have a plugin which can retrieve those REST API, this information via JMX or REST API based on a pre-built plugin specific to Hazelcast. Diagnostics. Diagnostics are Hazelcast internal probes. The whole system is picked with probes at pretty much every single point. And the idea is that it was initially created for our own performance team because they wanted to understand what is actually going on deep in the system. When something is slow, how it becomes slow and where the time is spent. But now we actually have this information available to the customer, so the customer is able to activate probes at an operation level as well, which means when you, for example, have a support request and there's something really fishy going on and something is slow, the support team might actually ask you for a diagnostics log and it is actually pretty simple to activate. There's a lot of different information in there. As I said, there's invocations, there's pending invocations, slow operations, build information, system properties, operation properties, information about system overload, pretty much everything. So if you have a slow operation, we can actually from the probe see, okay, it spent that much time waiting for being processed. It spent that much time being transformed into a byte stream that we can send over the wire. It took so long to actually send it through the wire. On the other side, it had to wait for being executed. And those information, so you see exactly where the operation becomes slow. Is it an overloaded network? Is it maybe not enough cores or not enough memory on the other side of the system? Those kind of things, or maybe just a thread count, right? Those kinds of things are visible from the log. At the moment, you have to restart the cluster to activate the logs, or to activate the diagnostics. That is one of the points where you might have to restart the cluster. So the best way, and I think that is common knowledge, you should always have a second setup, which is similar to the production setup. So in this case, you can just restart like the staging area with diagnostics, and you can try to replay traffic or just trying to figure out what is going on. Maybe what we did at another company work for, we actually had a traffic splitter. So we used the live traffic coming in and split it into two different systems, one for staging, one for production. And we created also load tests like that. But you obviously have to have the option to do that. Configuration is simple. As I said, it's a couple of JVM properties you put on the command line. You enable the diagnostics. You put the diagnostic level to one of the three levels. I think it's mandatory, info, and full, or something like that. And then you have multiple properties to activate or deactivate specific diagnostic types. Like in this case, you can activate invocations, pending operations, and whatever else in the system. So maybe you don't need to collect everything. So it might make more sense to put some of these things to false, for example, to activate or deactivate them. Near caching. Near caching is about adding a separate layer of cache to clients or members. Most specifically, it's normally used for clients. That means you have the Hazelcast cluster, and you have a separate small cache inside of your local application, which keeps like the most frequently, the most or the last used elements close to the application itself, so you can avoid the additional network round trips. So if you, for example, or if the application requests the same element like 5 or 6 times, you don't always have to go through the cluster, capture the element, or retrieve the element, but you can actually go to the near cache and say, okay, I already have that. So obviously for the first time you go through the network, but afterwards you can see, okay, I have this element already on site, so I'm going to use that one. That speeds up the access times even further, but has a little trade-off, because it means that you have this like little chance or very narrow chance of reading some stale data where the actual element is already updated in the cluster, but not yet on the client. So as I said, the way it works is you have a client, and that one goes to the near cache, figures out it's not yet in the near cache, so the near cache actually has to go to the cluster, retrieve the element, store it locally, and return it to your requester, which is the application itself, and for the next request, it will just take the near cache element directly. So pretty simple concept. As I said, the problem is it might be updated in the cluster right now, but it's not yet updated in the near cache. Or better said, it is not yet invalidated. So the way it works is you update something in the cluster, and the cluster will tell the near cache, hey, this element was updated, please remove it from your near cache. And the next request will start over and go down to the cluster again. And we have 10 more minutes and 2 more points, so I think we're good in time. General system optimizations, and here starts the part where there is like not really the option to have any cool pictures anymore. So the slides look a little bit more unfancy. As I said, as I already said, like a little recap, partition count and partition size. So we have 271 partitions by default. We should definitely increase this number to a higher prime number when we hit the 50 nodes, or when we figure out that partition size, so the size of a single partition increases over 50 to 70. The other page said 100 megabytes. I wouldn't even go that far. I would see 70, as you remember, in case something or one node fails, we have to take over more information. So you definitely have to go with that, and you have to increase. If you have more than 100 megabytes, that is the second reason why you actually want to do that. Near caching, we just had that. As I said, data consistency versus data access time or access frequency. You have to look into that. Garbage collection, we talked about that. I would just want to highlight two things here. That is a jClarity Sensum and a GC Easy IO. So in case you have GC logs, those two tools are an amazingly great helper for figuring out what is actually going on in the GC logs, and jClarity Sensum also gives you some information on how optimizing the GC might work, or what parameter you want to try. The other option is going for HTMS to move the data out of the GC area, which is often a very quick win. Serialization, my personal favorite. If you really have a slow going system, or when we are somewhere going on site for a slow going system, the first thing we test or we look out for is serialization. Unfortunately, a lot of people still use Java serializable, which is very bad in terms of speed and size. You see, there's a couple of options. You definitely need help from engineering for that. But that is something, if you figure out there's a slow running cluster, that is something to mention to engineering, like, hey, let's look into that. Query indexes, I guess that is obvious. Like for relational database, indexing improves query speed. So you can have ordered, unordered indexes. Like an ordered index means if I have multiple numbers, it will actually naturally order the numbers already. So if I look out for a user with an H, I know where I have to start and where I have to end. Thread pools, there's a lot of different thread pools, as I said earlier, and there is a thread pool for pretty much every single feature. They all have their individual thread counts and thread sizes, so there's a lot of optimization potential here. And you see, you figure out I'm going a bit faster because I really want to have a little bit time for the Q&A. So there is this different thread counts, and there's a lot of potential to optimize here. However, I would always say come back to support and to solution architects to ask if you want to change one of these values, and we're happy to help out in any kind of optimization or any kind of recommendation for those thread counts, especially because they heavily depend on the number of CPU cores. One important thing for operations, however, is the TCP buffer size. So you have to configure the buffers twice in Hazelcast for the Java side, and obviously in Linux for the TCP socket layer size. I think those elements or those values are pretty known, of those properties. You can manually configure it. You can have the Linux kernel optimize it for you automatically. However, when you change the value in Hazelcast, it most of the time makes sense to change it to the same value in Linux, which means you're going for a manual configuration. And with that, the last point is happy Hazelcasting. There is the documentation. The documentation has a lot of information as well. Just skip all the engineering part if you're not deep into programming. There's also a lot of information for the deployment and for the operations side of view. And the second link is the same thing that I already mentioned in the first or in the second slide. You remember the bit.ly/hz-operations. That is the long version of it. But I think we share the slides anyways, as far as I know. So feel free to just click on it. It's probably easier. And with that, I think we're going to the questions. And there are a couple of questions. So the first question is, does Hazelcast support the Citrix Zen server deployment option? I don't know of any customer yet running on Zen server. There are probably some open source users, but it's definitely not one of the supported options we have right now. So it's not officially supported, at least. But if that is necessary, we're always happy to support more environments. It's just that we just make something official when we know that it is running perfectly fine. So we might have to set up a Zen server setup to figure out if there are any issues or any problems with Zen server. Otherwise, normally I would say you're good to go. The second option is related to the big GC pause times. And if you increase heartbeat time to, for example, 5 minutes. Okay, yeah. Sorry, took a second. So you can change the time for a heartbeat between Hazelcast members. Yes, it would solve the GC pause problem. However, during the GC pause, all the information or all the records stored on the specific machine that is in GC pause will not be available and will most probably block other requests as well. So you can do that. It is definitely not recommended, especially when you lose one node, and especially when you're going for virtualized environments, you're more common to lose a node. In this case, it will take 5 minutes to figure out that the cluster is not reachable anymore, and it will actually take multiple heartbeats, which might end up to being 15 minutes before the node is removed from the cluster. So you really don't want to do those kinds of things. Is it possible for older Hazelcast versions before 3.6 to talk to later versions? Unfortunately, no. We changed the client, so I guess it is the communication protocol between cluster and client. No, because the cluster changed with 3.6 to integrate this version-independent protocol. So no, if you're still before 3.6, you have to do at least one time a full shot update, otherwise it won't work. Can you quickly explain why you should not activate JMX on the node? As I said, JMX is a very GC unfriendly protocol. That the problem is you run into the same GC issues. So when you activate JMX on a JVM, it will do a force full GC every couple of minutes, I think every 10 minutes or something. And depending on the size of the heap, you can have your application and the cluster and the GC optimized as perfectly as you want to. It will still run into a full GC, and you really don't want to have those kind of situations. Therefore, I would never recommend to activate JMX on any kind of node related to a JVM that is supposed to work and not to wait. What can we do to minimize problems on OpenShift private cloud? Unfortunately, I'm not 100% sure by the question what are the problems, but feel free to send an email to chris@hazelcast.com and explain the problems, and we can see what we can do about that. Security feature you mentioned in 3.9. What I said is that we integrated the OpenSSL stack, so we have the option to not use the JVM built-in SSL library anymore, but we can use the native OpenSSL library, which improves speed massively. It almost doubles the speed and goes close to the, or brings encrypted throughput close to the unencrypted one, which is a very major benefit for 3.9. When is Hazelcast 3.9 to be released? We're aiming for end of September, but since we put quality and stability over a timely release, it might be a little bit later. So we really make sure that we release something, we really want to make sure that we release something stable and that we're not putting something out just because it's time, right? So imagine it's somewhere end of September, early October to mid of October, something like that. What to use instead of Java serializable? There are a couple of options in the slide deck. There is also a couple of options in the operations guide. So for a quick win, I would recommend KRYO, Creo, which is, I guess, from some German team. You don't really have to code a lot of stuff to make it happen. It is very fast. It creates a concise byte stream. Otherwise, there's a couple of options coming internally from Hazelcast that also solve this issue quite easily. When upgrading, you mentioned rolling upgrade at node level. Is rolling upgrade feasible for at data center level, meaning upgrade one data center? Well, okay. So I think the question is about, does rolling upgrade work for WAN replication or for data center replication? To be honest, I'm not 100% sure what rolling upgrade means in this case. I guess you want to upgrade one data center first and then the second. To be honest, I'm not 100% sure this is supported. I would definitely need to ask that to someone who knows, most probably engineering. Same here. Please send me a mail to chris@hazelcast.com, or I think you all have the invite and you might have some contact address. So just send me the question again and I'll try to figure it out for you. When should you go with replicated map over partition map? So one thing I haven't mentioned is the Hazelcast replicated map. So the way it works is, as I said, by default, Hazelcast partitions the data, or shards the data, whatever you're going to call it. So every node keeps a subset, but we have one specific data structure, which is replicated map, which replicates the information to all nodes. So every node has the same data. However, the use case is very specific since the replication is actually async. So there is a very high chance that you see data which is not up to date, and we're not doing any kind of write consistency. And so we're not asking multiple nodes for what is the most returned value. So replicated map has the specific use case where it was, has one specific use case from my point of view, and that is where it was created for everything where you want to have an extremely fast access, but you can, in the worst case, if the data is not available or if the data is stale, it doesn't really matter. Like a good example would be, for example, YouTube. Somebody uploads a new YouTube video, but replication to the different nodes takes a bit of time. So user one opens the YouTube video page or the YouTube page. He sees the new video. The other one sees it only 5 minutes later. So in this case, you can use the replicated map because it doesn't really matter when the information is available. For anything that needs to be consistent, it doesn't work because you have no read guarantee. Is there possible inbuilt Heartbeat API for WAN replication clusters? I'm not 100% sure what that question means. Same thing, please send me the question in a little bit more detail, so I'll try to answer it afterwards. Is it okay to use key value repository pattern provided by Spring? Will it impact performance in any ways? I'm not 100% familiar with the key value repository pattern, but I think that is coming from Spring Data. Hazelcast has a Spring Data integration, so you're perfectly good to go with that. But the other option is you can also use the Jcache API, which has those annotations, which are supported by Spring, built into the specification, and that would work as well. That way, you build your own, you build your repository using the original API or using the original database, for example, MongoDB or whatever, and you just put the annotations into it, and Spring will make sure that the data is automatically pushed into Hazelcast for caching and retrieved if it's already available. And the last one, what about transaction support? If yes, does it support nested transactions? Yes, we have transaction support. However, I always recommend to keep it out of the system as long as possible. Because the problem is the second you use transactions, you have about 1/4 of the speed because of the synchronization overhead. That means when you start a transaction, you have to make sure that if the node that actually operates on the transaction fails, you can roll back it. So that means you have a lot of overhead for synchronizing it. So yes, we have it. I'm not 100% sure what nested transactions are. I think I've never used them. So I can't really answer on the second part. But as I said, yes, we have transaction. We actually have JTXA support, which is the Java Enterprise or Java EE transaction API. You can use it, but please use it in a careful fashion. I think that is the right way. And I guess that was the last question. Oh, no, it was not. Just had to scroll down a bit. Is there a way to check if the cluster is safe? Or if the members are safe? Yes. You can either use the management center, or there is a specific REST API call which returns just plain text, giving you the specific states of the member, of the cluster in general. And that is, for example, created for something like OpenShift, Kubernetes, where you just have like a simple shell script, like an awk or a set script, or for things like F5 routers or load balancers that can mostly or only work nicely on plain text data. But again, feel free to see the documentation. There is a chapter about it, how it works. It's fairly easy. It's just one property, so you activate it because it's deactivated by default, and then you can retrieve it automatically. Are there any performance optimization pointers in Hazelcast docs? They are, but more for the development side of things. So for developers, there are some points. For DevOps and operations, I definitely and I highly recommend the deployment and operations guide found on the Hazelcast website. Nested nested transaction. I just got the answer. Nested transaction just means participating in an existing transactions. Yes, as long as you use JTXA, so the Java Transaction API. In this case, Hazelcast will, like WebLogic and kind of things. In this case, Hazelcast will automatically take part of the transaction that is already open. And that was the last question. He was not. I think you guys are adding more and more questions. Is that possible? I have 2 more questions right now, and any kind of other question, feel free to post it to the Google groups or Stack Overflow. I'm happy to answer it, or in the worst case, just write me the email. So the last 2 questions. Read from backup. So there is a property which is called, or there is an option you can activate, which is called read from backup. That means when you have, as I said, we always have one backup by default. So when you have this backup, you can configure it to be available as a read source. So you have actually two nodes in this case, the actual record owner and the backup owner, to be available for reading. But it pretty much like in Nearcache, it gives you a bigger trade-off between availability of the data, because now you have two nodes that you could actually ask, and the consistency, because the owner might just update a value which is not yet in the backup, and you read the stale information. So read from backup again gives you this trade-off between speed and data consistency. And the last one, rather than using JMX on nodes, can we monitor using REST? No, REST is only available on the management center. So the nodes only can activate JMX or push the information to management center, but management center has a full-blown REST API for making those values available. Okay, I hope that answers like most of the questions. As I said, if you have any more questions, feel free. We have the Google groups, which is called Hazelcast. We have Stack Overflow. Please use the hashtag Hazelcast. And with that, I definitely say thank you. It was very nice. There was a lot of questions, which means there's a lot of interest in this topic, also from operations side. So thank you very much. And I'm giving back to Ben.
Great, thanks, Chris. Thanks everybody for the questions, and thanks for staying along so we could get through those. Appreciate that. Everyone, have a great day, and again, thanks for attending.